Imagine we write a program once and we want the same program to run on different types of computers without rewriting everything. This is the main idea behind Kokkos and Raja. Today I am going to explain what Kokkos and Raja are, why they are useful, and how they help us write portable and high performance programs. I'm EAWD Dharmaratna. This is for parallel programming models and platforms. Modern high-performance computers use different types of hardware. For example, Frontier uses AMD GPUs while Aurora uses Intel GPUs. These systems can use different programming technologies such as HIP and SYCL. The problem is that writing separate code for every type of hardware takes a lot of time and effort, so we need a better solution. There are two extreme choices. The first is to write special code for each hardware type. This can give very high performance, but we need many different versions of the same program. The second is to write very general code that can run anywhere, but then we may lose a lot of performance. Kokkos and Raja try to give us the middle solution, good performance with one main code base. There are different ways to make programs portable. One way is using directives such as OpenMP and OpenACC. We add special instructions to existing loops. Another way is using C++ libraries. Kokkos and Raja use this second approach. They use C++ templates and functions to express parallel operations, while the system chooses the suitable backend during compilation. Now let's look at Kokkos. Kokkos is a C++ library developed by Sandia National Laboratories. Its main goal is performance portability. It allows the same C++ program to work with different technologies such as CUDA, HIP, SYCL, and OpenMP. So instead of writing completely different programs for different hardware, we can maintain one main code base. Kokkos has several important concepts. First, execution spaces decide where the program runs, such as CPU or GPU. Second, memory spaces manage where the data is stored. Third, Kokkos provides views, which are used to manage arrays and data efficiently. Finally, it provides parallel operations such as parallel for and parallel reduce. These features help us separate our program logic from the specific hardware. This slide shows a simple Kokkos example. Here, we calculate values using the parallel for. The important point is that we don't need to write separate code for every hardware platforms. The same source code can be compiled for different backends such as CUDA, HIP, SYCL or OpenMP. So Kokkos help us save development and maintenance time. Next, we have Raja. Raja was developed at Lawrence Livermore National Laboratory. Like Kokkos, Raja helps developers write portable and high-performance C++ programs. But Raja has a more modular approach. It focuses mainly on making loops portable, while other tools can handle memory and data movement. Raja has three main parts. Raja handles loop execution. Umpire helps with memory management, and Chai helps move data between the CPU and GPU. Together, these tools provide a flexible way to make existing applications portable. In this example, the main loop stays almost the same. The important part is the execution policy. For example, we can select sequential execution, OpenMP, CUDA, or HIP by changing the execution policy. So instead of rewriting the loop, we mainly change how and where the loops run. Now let's compare them. Kokkos is a more integrated library and uses views for data management. Raja is a more modular and works together with Ampere and Chai. Kokkos supports CUDA, HIP, SYCL, and OpenMP, while Raja has strong support for CUDA, HIP, and OpenMP. So both provide portability, but they use slightly different approaches. These technologies are not only theoretical. Kokkos and Raja are used in large-scale scientific computing and exascale systems. For example, Kokkos has been used with applications such as VPIC, and Raja supports large-scale simulation codes at Lawrence Livermore National Laboratory. This shows these frameworks can be useful for real-world high-performance computing. So, what can we learn from this? First, modern computers have different types of hardware, so portability is very important. Second, Kokkos and Raja allow use to one C++ code base across different platforms. Third, Kokkos focuses on an integrated approach, while Raja focuses more on modular components. And finally, both aim to provide high performance without requiring completely different code from every platform. To conclude, Kokkos and Raja make parallel programming easier to manage across different hardware. Instead of maintaining many different versions of the same program, developers can use a common C++ code base and target different architectures. So the main idea is simple: write once, run efficiently on many different systems. Thank you.